All right, so today we're diving into something that's like uh, the backbone of making a ton of biotech stuff.
Hmm.
It's basically how we separate cells from the liquid they've been growing in.
Okay.
You sent over some really cool material about this stuff, like from industrial biotech and downstream processing.
Right.
And I think our goal here is to like really understand how the main filtration techniques work for this.
Yeah.
This might sound kind of technical, but trust me, understanding this is like the key to getting everything from,
Yeah,
medicines to like the enzymes that are in our laundry detergent.
exactly. It's like imagine you're brewing beer,
Mm-hmm.
but like on a massive scale
Okay.
and like super controlled. You've got your, valuable product all mixed in with the yeast and everything else.
Right.
Filtration is like one of the main ways we carefully take that product out by getting rid of the cells and all the other bits and pieces.
Okay, cool.
Our sources really focus on two main approaches.
Yeah.
There's depth filtration and then there's surface filtration,
Okay.
also known as membrane filtration,
Gotcha.
which includes things like microfiltration and ultrafiltration.
Okay, so those are like the big
Well,
categories.
those are like the cornerstones of how this separation happens.
So depth filtration first. The name kind of gives it away. It's not just like a surface level thing, is it?
Not at all. It's think of it like trying to catch sand in a really thick sponge,
Okay.
or even better, like a tangled spider web, with all those fibers.
I see.
As the liquid goes through this porous material, all those cells and other particles, they get stuck inside the whole depth of the filter.
Oh, so it's not just catching on the top.
No, it's like throughout the whole thing.
Interesting.
This is really useful when you have a lot of cells to remove right at the beginning,
Makes sense.
because it can handle like a really high load of solids.
Oh, okay.
And what's cool is that these filters can be designed with like different materials and thicknesses depending on what you need for the specific process.
So it's like the first heavy-duty step to clean up the bulk of it.
Right, exactly.
Then we go to surface filtration or membrane filtration, and this sounds like it's got to be more precise.
Yeah, this uses a thin membrane, but it has very, very specific pore sizes, like right on the surface.
Ah,
So it acts more like a really fine sieve. Anything larger than those tiny holes can't get through. It gets held back
okay.
while the liquid and the smaller molecules pass through.
I see. So that's where microfiltration and ultrafiltration come in.
Exactly.
But what makes us choose one over the other?
It all comes down to the size of those pores.
Okay.
Microfiltration membranes have larger pores, so they're perfect for removing bigger things like whole cells bacteria and bigger pieces of cellular debris.
Gotcha.
Ultrafiltration membranes, on the other hand, have much smaller pores, so they can even catch smaller molecules, like sometimes even proteins,
Wow.
and they still let water and smaller dissolved stuff pass through.
So it really depends on what you're trying to get.
Yeah, it totally depends on what you're trying to keep and what you're trying to get rid of.
Like if you want a specific protein?
Yeah, for example, if you're working with very delicate proteins, you have to think about the forces involved in certain types of filtration.
Oh, like it could damage them.
Exactly. The wrong kind of filtration could damage those proteins.
That makes a lot of sense.
So thinking about that whole process, if we wanted to collect a protein that the cells have released,
Mm-hmm.
we might start with microfiltration to get rid of the cells themselves first,
Right.
and then maybe use ultrafiltration to actually concentrate that protein.
Oh, that's cool. It's like a two-step process.
Exactly. That's a super common way to do it in downstream processing.
So what are like some of the biggest challenges you think someone would run into when they're trying to pick the right filtration method?
That's a good question.
I mean, it seems like you need to know the size of what you're working with.
Absolutely.
Yeah.
You need to know the size of both the cells and the target molecule.
Right.
And then there's also the cost factor.
Yeah, because some of these must be really expensive.
Some are definitely pricier than others.
And like how easy it is to scale up.
Yes, exactly.
Right.
How do you go from a small lab setting to industrial scale?
Yeah.
And on top of that, different starting liquids
Yeah.
can have such different properties.
Oh, right.
Like filtering something super viscous, almost like syrup,
Huh?
is a whole different challenge compared to filtering water.
That's true.
And, while we're focused on filtration today, it's worth remembering that there are other methods.
Right.
Things like centrifugation are really important too, especially in those early stages for bulk separation.
Okay.
That happens even before we might use filtration for finer purification.
So it's like a whole series of steps.
Exactly. It's a whole carefully designed process.
Okay, so to recap what we've talked about with filtration for removing cell mass, we've got depth filtration, where the cells are trapped inside a thick filter material.
Mm-hmm.
And surface filtration or membrane filtration, which uses a thin membrane with specific pore sizes
Right.
to separate things by size. And that includes microfiltration for larger particles like cells and bigger debris. And then ultrafiltration to separate even smaller molecules.
Yeah.
And both of these methods are crucial for getting those valuable products out of our bioprocesses.
Precisely. And it's easy to overlook these kind of technical details,
Right.
but they're honestly the foundation for creating medicines,
Yeah.
enzymes, and all those other important substances we use every day.
Yeah, they're like the unsung heroes.
Totally. They're critical for the whole manufacturing process.
So thinking about all the different kinds of filters and how precise those pore sizes can be,
Yeah.
what kind of accuracy do you think we need when we're purifying different biopharmaceutical products?
Hmm.
And then how does choosing a specific filtration method actually affect the final quality and the cost of making that product?
Those are some great questions to think about.
Yeah, it's a lot more to it than meets the eye.
Definitely, it's a whole world of its own.
Thanks for taking this deep dive with me.
Absolutely. This was fun.
I always learn something new.
Me too.
All right, until next time.
See ya.